an interesting result using the slope-intercept form of a line. So, you may be familiar with y equals mx plus b. This is the formula for a linear function. And you can also write this as f of x equals mx plus b, because it's a function. And we also have, you may be familiar with m equals y2 minus y1 over x2 minus x1, where m is just the slope of the line, change in y over change in x. I'll write that. So this is the formula for the slope of a line. And you may be wondering, if you don't already know what this is, what is y2, y1, x2, and x1? Well, x1, y1 is a point 1, let's just say, and x2, y2 is 0.2, could say, p2. So, where x1, y1 is not equal to x2, y2, so you can't have the same point, because what will happen is you'll have 0 over 0, indeterminate form. But anyway, so one day I was playing around with the slope of a line, and I realized that, okay, so we have slope can be so slope can be positive, negative, you may already know this, undefined, or just 0. So positive would be like this, negative would be like this, undefined is just straight up and down, and 0 is, horizontal. So I was thinking, what if we do this? What if we say m equals, m, the slope, equals a number over 0, and this equals, well, of course, the slope y2 minus y1 over x2 minus x1. And of course, this will be the slope for an undefined value, right? Because it cannot be 0 over 0, because then we're just taking the slope of 2 points that are the same thing. So we can do this. So we can say 0 times y2 minus y1 equals n times x2 minus x1, and then 0 times anything is 0. So we have n times x2 minus x1, we'll switch this, equals 0. Also, n is not equal to 0. I'll write that over there. And since this is not equal to 0, we can divide both sides by n to get x2 minus x1 equals 0. Or x2 equals x1, which means x1 equals x2. And I was thinking, hey, this makes a lot of sense. Show this graphically. So, if we have, straight up and down, just pretend this is straight. We have, this is one x point, so let's say this x equals 5. So this would be 5, 0, just the x-intercept. And then this goes straight up and down, so 5, 0, we have 5, 1, 5, 2, ... And I was thinking, hey, x1 equals x2. That makes complete sense, since if we take 2 points, to find the slope, we could say 5, 0 and 5, 1, Yeah, so 5, 0, and 5, 1. So change in y over change in x, right? Change in y would be 1 minus 0, and then we have over 5 minus 5. We have y2, y1, x2, x1. So even this is 1 over 0, even though this is undefined, we still get an interesting result that makes complete sense. And also we could do the same thing with 5, 2 and 5, 0, so that would just be 2 over 0. Still undefined. And yet this makes complete sense. So, let's see. Oh, and I also did the same thing with lines that have slope of 0, so y2 minus y1, along with lines that have positive and negative slope. So, over x2 minus x1 equals 0, and I said, oh, okay, 0 over n, where n is not equal to 0, of course, don't want 0 over 0. And we have multiply these two and these two. We have n times y2 minus y1 equals 0 times x2 minus x1. So this means n times y2 minus y1 equals 0. We can divide both sides by 0 because n is not equal to 0. So we get y2 minus y1 equals 0, which means y2 equals y1 and y1 equals y2. So this also makes complete sense because, if we have here, so this is the line. If we take 2 points, let's say like this and this, we have, let's say, okay, so we have 0, let's say 3. Here we have, let's say 4 and 3. Makes complete sense. y1 equals y2, y2 equals y1. So that also makes complete sense. And I actually did the same thing with positive and negative values, but that's not as interesting because you just get, let's see, you just get for m equals 1, we just get this equals y2 minus y1 over x2 minus x1. We just get x2 minus x1 equals y2 minus y1. Makes sense, right? So this equals this. These are equivalent, n and n. Makes sense, so the difference is the same for the x and y values. And also I did the same thing with m equals y2 minus y1 over x2 minus x1, which equals negative 1. Multiply both sides, so we get y2 minus y1 equals negative 1 times x2 minus x1. So we get y2 minus y1 equals x1 minus x2. This also makes sense, of course, because we have, goes like this. And we have from here to here, let's just say, and from here to here, just say, this is n. Change from here to here is n. Change from here to here is negative n. So, they're opposites. Change in y is opposite, like negative 1 times the change in x. And yeah, so that covers it all for positive, negative, 0, and undefined slopes. And yeah, so I hope you liked this video. I just sort of found this out a few days ago, and yeah, see you in the next video.